they were never meant to last this long. Born in an era of rotary phones and analog signals, the twin Voyager spacecraft were launched with hope, ambition, and technology that would soon become obsolete. Yet today, more than 47 years later, they drift alone, untouched by time, beyond the reach of the sun's light, deeper into the void than any human-made object in history. Launched in the 1970s with the goal of exploring the outer planets, they far outlived their original 5-year mission. Now they exist in silence, out in the vast unknown of interstellar space, where the stars are no longer a backdrop but the only company they keep. Billions of kilometers from Earth, they move slowly and silently through a place no spacecraft has ever gone. Interstellar space is not the blackness you see in science fiction. It is colder than imagination, quieter than silence itself, and full of invisible forces, magnetic fields, cosmic rays, and wisps of ancient gas from dying stars. In this alien sea, the sun has been reduced to a dim, ordinary star among thousands. Home is no longer visible. And yet, these two tiny machines continue their journey. No guidance. No corrections. Just momentum and memory. But what becomes of such a journey? What lies ahead for Voyager 1 and Voyager 2? Not in the next few years or decades, but in 1,000, 1,000,000, even 1,000,000,000 years. What happens when a spacecraft becomes a time capsule, adrift in eternity, carrying the fingerprints of a species that may one day be gone? Before we can understand their future, we need to understand where they came from, how this impossible odyssey began. It started with an opportunity, a rare alignment of the outer planets that occurs only once every 176 years. This cosmic window allowed a spacecraft to slingshot from one gas giant to the next, using their immense gravity to gain speed and redirect its path, a phenomenon known as a gravity assist. NASA seized the moment. The result was Voyager, not one probe but two. Identical in design, complementary in mission. They were built to survive the punishing conditions of deep space and launched with more than instruments, they carried humanity's message in a bottle. When Voyager 1 and Voyager 2 left Earth in 1977, they represented the pinnacle of 1970s engineering. Their onboard computers, revolutionary for the time, could handle just 68 kilobytes of memory, barely enough to store a single email today. They could process around 8,000 instructions per second. It was enough. Because it wasn't raw power that made them extraordinary, it was what they were pointed at. They visited giants. Jupiter, Saturn, Uranus, Neptune, colossal worlds previously reduced to blurred images through telescopes. Suddenly, the solar system exploded into color and chaos. Voyager 1 showed us Jupiter's atmosphere in motion, a swirling, roiling system of storms, some larger than Earth, raging for centuries. It revealed auroras dancing at the poles, rings so faint we didn't even know they existed. Saturn's rings, once thought to be a few simple bands, turned out to be an orchestra of icy particles, tens of thousands of ringlets interwoven like a cosmic lace. Voyager 2 took us even farther. To Uranus, a frozen blue world tilted so far on its axis it essentially rolls around the sun. Then to Neptune with its supersonic winds and methane storms. It spotted geysers on Triton erupting nitrogen into space, shooting into the frigid vacuum from a moon so cold that temperatures hover near absolute zero. It found volcanoes not on Earth but on Io, one of Jupiter's moons, where lava fountains burst from an alien crust. The discoveries rewrote science textbooks, but they also did something more profound. They made the solar system feel alive, dynamic, full of surprises. Europa. Enceladus. Two icy moons that were once overlooked, now considered prime candidates in the search for extraterrestrial life. Voyager showed us that beneath the surface of these frozen worlds, vast oceans might exist. And with oceans comes the possibility of life, not as we know it but as it could be. It was a revelation. One that forever altered how we define the habitable zone. The scope of the mission was staggering. Over 11,000 person-years were poured into Voyager. Every signal, every command, every photograph was touched by human hands. A collective act of ambition that spanned decades, generations, and still continues. But time is relentless even in space. Though Voyager was built with durability in mind, it wasn't expected to survive past the early 1980s. And yet, as the years passed and the planets faded into the background, the twin spacecraft kept going. The mission evolved. They had done what they were designed to do, but something more was now possible. They were headed out, beyond the solar system entirely. Beyond the reach of planets. Beyond even the sun's protective bubble. In 2012, Voyager 1 crossed that invisible boundary. It became the first human-made object to enter interstellar space. The heliopause, the edge where the solar wind weakens and the interstellar medium begins, marked a new frontier. 6 years later, Voyager 2 followed. No longer held in the sun's embrace, they were sailing through a place where the temperature is just above absolute zero, where cosmic radiation pulses through the dark, where atoms drift so thinly that space itself feels empty. The silence out here is not poetic, it is real. No other spacecraft can hear them. And yet, from all this distance they still speak to us. Each message takes over 22 hours to reach Earth. The signal is so faint, it's a whisper beneath the static, requiring the largest radio antennas on Earth just to detect. And even then, it's just a trickle of data, fractions of a kilobyte, crawling through space like a message in a bottle carried by the tide. But that trickle matters. Their nuclear hearts, plutonium-powered thermoelectric generators, are fading. Slowly. Irreversibly. When launched, they produced hundreds of watts of power. Now they have barely enough to keep a few instruments alive. One by one, the systems are being turned off. Heaters disabled, sensors silenced, the warmth that once protected them now gone. The spacecraft themselves are freezing. People often wonder, why don't we have photographs of interstellar space? Why haven't we seen what lies beyond the sun's influence? The truth is, the cameras are gone. Not physically but operationally. In 1990, the decision was made to shut them down to conserve power. Before that, Voyager 1 performed one last task, a gesture not of science but of perspective. It turned its camera homeward. From more than 6 billion kilometers away, it captured the solar system in a mosaic of images that would become known as the family portrait. Among them, a single frame containing Earth. Just a speck, less than a pixel, bathed in the scattered light of the sun. That speck became known as the pale blue dot. It was Carl Sagan who immortalized that image with words that echo through time. That's here. That's home. That's us. It reminded us that everything we've ever known, every love, every war, every moment in history, took place on that tiny, fragile dot. And then the camera was powered down forever. Voyager would no longer see. But it would continue to feel. It can still detect the density of plasma around it. It can still sense magnetic fields and measure cosmic rays. It can still send back precious data that tells us what it's like at the very edge of the sun's reach, and beyond. Each bit of information is like a touchstone from another world, a connection to the furthest we've ever traveled. But the end is approaching. Even now, the mission team, many of whom weren't even born when the probes launched, are making impossible decisions. Which instrument gets the last watts? Which system is turned off next? The spacecraft can no longer heat themselves. They are now colder than ever before. And yet, even as they freeze, they continue to send signals. Defiant. Persistent. Alive, in a way that only machines with purpose can be. In the coming years, power will dwindle to nothing. The last instruments will shut off. Communications will cease. The antennas will go silent. There will be no final signal, no goodbye. Just an absence. And then, nothing. But even then, Voyager won't be dead. Not truly. It will still be moving. Momentum is forever. Voyager 1 is hurtling through space at over 61,000 kilometers per hour. Voyager 2 not far behind. In the absence of friction, nothing will stop them. They will continue on for millennia, passing through the galaxy, star to star, era to era. Their golden records, time capsules etched with the sights and sounds of Earth, will outlive everything we know. They carry greetings in 55 languages. Music from Bach to Chuck Berry. Images of human life, of animals, of DNA, of planets. They are the story of us, frozen in time and launched into the unknown. And that, more than the data, more than the photographs, more than the science, is Voyager's legacy. Not what it discovered but what it represents, the need to explore, to reach beyond, to leave something of ourselves behind in the vastness of space, in the hope that one day someone, or something, might find it and know we were here. As of 2025, Voyager 1 is more than 24.8 billion kilometers, around 15 billion miles, from home. Voyager 2 trails not far behind, sailing through the void at a distance of 20.8 billion kilometers, or about 13 billion miles. The radio signals they send, traveling at the speed of light, now take over 23 hours to reach Earth. That's nearly a full day just to hear a whisper from a machine built when disco was still on the charts. Their voices are faint, delicate threads stretched across the cosmos, received by massive antennas on Earth that must strain to pick them out from the background noise of the universe. It's a quiet conversation across time and space. But even these threads are unraveling. Each year, the Voyager spacecraft lose around 4 watts of power from their radioisotope thermoelectric generators, the tiny nuclear hearts that have kept them warm and alive since 1977. This slow fade has forced the mission team to make agonizing choices about which instruments to turn off, which pieces of science to surrender in order to keep others running just a little longer. It's like deciding which organ to shut down in a fading patient. There's no reset button, no spare parts, no rescue mission. Only strategy, patience, and a dwindling supply of hope. Yet still they endure. The question then isn't if the Voyagers will go dark, but when. Barring some miracle or unforeseen quirk of physics, the final instruments are expected to shut down in the early 2030s. After that, the spacecraft will fall silent. No more data. No more status updates. Just a vanishing signal swallowed by the deep. And yet, that will not be the end. It will be a beginning of a different kind, a quiet continuation of their journey, not as active explorers, but as relics of a species that once dared to reach for the stars. They will keep moving. Nowhere fast but always forward. Not until around 30,000 years from now will the Voyagers pass through the Oort cloud, that distant, frozen shell of comets and icy fragments that orbits the sun like a ghostly halo. It is the very edge of the solar system, our true cosmic shoreline. Once they slip past it, the probes will be bound no longer by our star's pull. They will be governed instead by the gravity of other stars, subtly, slowly bending their trajectories over unimaginable distances and timescales. If nothing catastrophic happens, Voyager 1 will fly within about 1.6 light-years of a star called Gliese 445 in roughly 40,000 years. It won't stop. It won't be pulled in. It will just drift past, a silent stranger passing through someone else's sky. Voyager 2 meanwhile is on a different path. It's heading toward Ross 248, a star that it will approach to within 1.7 light-years, also around 40,000 years from now. These encounters won't be close enough for the probes to be captured or noticed. But that's never been the point. Because the Voyagers were never just about science. They were about story. About sending a piece of ourselves into the universe just in case someone out there was listening. That's where the golden record comes in. Each spacecraft carries one, a 12-inch gold-plated copper disc, sealed in an aluminum cover, etched with instructions for how to play it. It's a time capsule of Earth, of us. It contains sounds of waves and wind, the calls of animals, greetings in 55 languages, and music from around the globe, from Bach to Blind Willie Johnson. It includes diagrams and photos encoded as signals, showing human anatomy, DNA, mathematical concepts, and scenes of daily life. It even features the brainwaves of a young woman thinking about love. It's not meant for us. It's not even really meant for aliens. It's meant for the cosmos, for time itself. Carl Sagan, who helped conceive the golden record, said it best. The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. Hope, not in finding someone but in being found. In saying, we were here. We tried. We reached. And the reaching goes on, far into a future we can scarcely comprehend. In about 250 million years, the entire solar system, including the tiny paths of both Voyager probes, will complete a full orbit around the Milky Way galaxy. That's a quarter-billion-year journey around our galactic core. By that time, Earth's continents will have shifted beyond recognition. Mountains will have risen and fallen. Languages, cultures, perhaps even species will have come and gone. But the Voyagers may still be out there, ancient, battered, drifting. Interstellar space, though empty, is not without hazards. It's full of dust, tiny grains moving at incredible speeds. These particles, though microscopic, strike the spacecraft like bullets. Over the millennia, they chip away at metal, carving pockmarks and scars across the spacecraft's skin. A grain just 1,000th of a millimeter wide can leave a crater. And though this slow erosion won't destroy the Voyagers anytime soon, over millions of years it will wear them down, leaving them dented, pitted, ghost-like in form. Gravitational nudges from passing stars, gas clouds, or rogue planets could also bend their trajectories. These aren't predictable forces. They unfold over timescales and across distances beyond our ability to track. One day, a distant star's tug might pull Voyager into a new orbit. It might pass through the heart of a nebula, or skim the edge of a binary system. It might tumble, spin, or coast steadily on. And yet, unless they are destroyed by a rare and powerful collision, the Voyagers are likely to remain at least partially intact for billions of years. Some estimates suggest they could survive even into the age when our own galaxy collides with Andromeda, an epic merger expected to occur around 5 billion years from now. When that happens, our starry sky will look completely different. Constellations will vanish. New stars will be born in titanic firestorms. And through it all, the Voyagers might still be drifting, oblivious, ageless, eternal. That far future is impossible to picture. But if they survive it, if they ride out the chaos of galaxy-scale collisions and avoid annihilation, then they could last even longer. Trillions of years longer. Into an age when the universe itself grows cold and dark, as stars burn out and only remnants remain. A time of black holes and white dwarfs, of silent galaxies and frozen planets. A cosmic graveyard. And still, somewhere in that darkness, two human-made objects may persist. Of all their components, the golden record is the most likely to endure. Made of copper, plated in gold, and shielded within its case, it was built not to function but to survive. To carry our voice long after we're gone. Maybe, someday far beyond our imagining, someone will find it. They'll decode the diagrams. They'll play the music. They'll hear the sound of a baby crying, of a mother's kiss, of thunder, laughter, a heartbeat. And in that moment they will know we once existed. That we loved. That we built. That we dreamed. The Voyager mission is not just a scientific triumph. It's a monument to what it means to be human. Fragile, fleeting, curious. We don't know if the message will ever be read. But we send it anyway. Because the act of sending it was enough. If you've made it this far, thank you. And now, if I may, over 86% of people who watch these videos aren't subscribed. But if you're still here, then you are exactly the kind of person I make these stories for. V101 Space is approaching 1 million subscribers, and I'd love for you to be part of that journey. So please consider subscribing. It helps more than you might think. And if you want to go even further and support this channel directly, you can become a V101 member or patron. The links are in the description. Your support keeps this mission going, and in return you'll get exclusive content, behind-the-scenes updates, and your name featured at the end of each video as part of the V101 crew. Whatever you decide, thank you for watching. And wherever you are, look up tonight, and know that somewhere out there, beyond the stars, two tiny spacecraft are still flying, still carrying a message from Earth.